do we work so hard to get to acceleration? So if you look at the x position of the ball in these two frames, they are different, so we cannot use position to construct physics law. If you look at the velocity, in a trees frame, the x of the ball is increasing, so it has an x velocity non-zero. In the boys frame, the x velocity of the ball is 0 because it's staying at the same x position. Still, when x velocity is different, they are not the same. It's not going to be a good thing to construct physics law. But if you take a slope again, a flat line has 0 slope, and a flat line has 0 slope. So when you get to acceleration, you finally find that it's the same in all frames. Okay? So the reason we get to acceleration is because acceleration is frame dependent, and the way physics law works is that all frames should agree on the same prediction. So what you should do is to predict a frame dependent quantity based on the physics law. So everyone agree that the acceleration of the thing right now should be this big. And then you go from the acceleration to predict velocity and position. You might think that the 0 equals 0 is trivial, but if you remember that the y position of the ball is the same in both frames. So if you look at the yt graph, there will be curve and there will be the same. So the velocity will be the same and the y acceleration will be the same and non-zero. At the end, you can check that both the x and y acceleration of the ball is the same in two frames. So they are the same. They are frame dependent. We finally have a frame dependent variable called acceleration. Any question? Good. So we found that the acceleration in all the frames is the same. This is an example of how exactly that works. On top is 4 different xt graphs. And the thing is that these two xt graphs, even though they look different, correspond to the same bxt graph. You can see that the bottom of it has a slope of 0. So at t equals 1, the x velocity of these two graphs both correspond to 0. So that's why they both correspond to this graph. The x velocity goes down and then up, so the downward corresponds to negative bx, upward corresponds to positive bx. And that's why they correspond to the same bxt graph. The only difference is that they start at different initial positions. If you look at these two graphs, you are just shifting this curve downward a little bit to get here. So they are just starting, or they are defining their starting point at different positions. It corresponded to two frames, probably a tree and another tree. As a tree. So what you're looking between these two is what these two different trees is. They think that stuff is moving equally fast, but the position is different because they have this different origin. And if you look at the other two xt graph, these two xt graphs also correspond to the same xt graph. And the x position just keep going up. So the velocity corresponding to them is always positive and increase. And if you look at acceleration, all these 4 frames has the same acceleration because the slope of the bxt graph is the same even though they start with different initial velocity. Okay? So you see acceleration to velocity is now 1-to-1. You have a lot of different xt graphs corresponding to one at graph, so that's why when you're doing physics law, you can have the same prediction, but end up with different position and velocity because you need to specify which frame you are doing, or which frame you are describing your motion with. Okay? Good. Now I have to stop the camera again. There must be a better way. I'll figure it out.